back up to a new video in my 7¼ inch gauge series, and last time we left off it was an open day and I haven't really done much on the loco. It's been sitting in a shed, but actually I was doing some drawing in the computer because I wanted to add some details. So this video is about like what I've been doing and just show you some of the things that I managed to do in the last couple of months when, you know, it was winter and I can't really do much outside. So the main changes I want to do is to the side of the loco, because I felt that this big blue section here is a lot of open space that I wanted to break up, because here I had the grills and the doors, so that sort of like break up this big surface, but there was nothing really here. I had this plate here which it's like, you know, when it was manufactured, and some, you know, funny play with the words, but I wanted to have some other things. So the first thing is I wanted to have like a number plate for the loco, and I've taken the designs from the old Hungarian Railways design. So I had these, and this now shows V49. So in Hungary, in the old days before the EU, electric locos were all V prefixed, and diesel locos were M. And the 4 letters is always the number of axles. So V40 is like 4 axle electric locos, and the zeros and the ones and everything was already taken by existing locos or some experimental locos, but instead of 9. So this fantasy loco is going to be V49, and while 1976 is the year I was born. So it could have been either 2022 or 1976, but I thought 1976 is a little bit more fancy. So that's one thing which I'm going to add here. So at the moment it's just held on by double-sided tape. And for the bogies I added, this is also 3D printed if you remember from the previous videos. So this is like a sandbox, and I thought maybe I can just have something like which feels like a filler cap. And I was also playing around with 2 type of vents, and I don't know where the other type is. So this is like a small side grill, and I've just done another version which is it has bigger louves, and I'm supposed to have it here, but I don't remember where I've put it. So that's one. And I have some brake pipe details on the front, which I'm going to show you a little bit close-up view of that. So this is the that's the lever or the valve part, and I also have a small part for the hose, and it has a small magnet, and that's going to stick on the surface like that. At least that's the plan. And I also have these small details that I 3D printed, and that's going to go on the top like here, and that's going to hold a small walkway up here. Again, I'm going to bring it close. And I also have some details for the axle boxes, and that's just going to cover the bearing block, and I think it looks fine. So let's look at some of these details a little bit closer. So as I said, side grill, number plate, sand filler. So I'm thinking that have another one here, so it's be symmetrical, and that's another design of the side grill. You know, nothing really complicated, just some just some bigger louves, a couple of screw holes or mounts just for imitation. And I think I'm going to keep this sideways, so something like that, like this. So again, just to break up the surface. It doesn't have to be symmetrical or anything like that. In fact, I'm guessing it's better if it's not trying to be symmetrical. So this could be like vents for, I don't know, something which is inside, something smaller than these bigger vents which is up here. Let's talk about the details on the front. So the two lamps, I ordered the missing red LEDs here, so they have arrived. I just need to put them here. These big holes are going to be for the remote control, and I printed these valves, and I think originally I had the idea just to have two of them, so this is why I have two small holes here and there, but I think there is just not enough space for two, because the other one would, yeah, I just have to print a symmetrical one, which, I mean, I just don't have enough space for two of them, so I think I'm just going to have one, and the other one is going to be like here, because anyway it gets a little bit too close for the coupler. I want to have enough space here so I just don't accidentally bump into these and I break these details. I mean, this is all 3D printed, so nothing, you know, structure. Again, these buffers could be a little bit longer, but that's what I have at the moment. And as I mentioned previously, so this is hose for a fuel line from a car, and there is a magnet here because I don't have a hole here, so I thought maybe I can just drill a hole, or maybe I can just use a magnet, and it seems to be holding just fine. So even if it catches onto something, it's hopefully not going to break off, but the magnet is just going to let go. At least that's the idea, and of course that can be held on with a screw through these holes, and I think I'm just not going to use the other holes, and still it gives me enough access for the cable to plug in here and still leave a little bit of room for my hand so I can reach it like that. But yeah, I mean, I just started drawing this, nothing, you know, fancy, but I think it looks good. Yeah. And since I'm up in the front, so these are these roof details. I already printed quite a few of them, and they have a matching slope with the roof, so I think it's going to be something like that, and I would have some thin pieces of some sort of wood which is going to sit on here, so that would be like a walkway, which is quite typical in older style locos, and if I'm lucky, yeah, they still have space under the pantograph, and yeah, that's just as a side plate. So I need to print a few of more of these, and I think I also need, I'm thinking that I'm going to also build a or 3D print a drilling template, so I can mount this relative to the edge of the roof, so I can just drill all of these at the same place. And probably I have to use some sort of screws from the underside, so probably I will need a nut here. And thinking about this whole setup, the only thing that I haven't really thought through is I won't be able to drill this hole because the side plate is here. So unless I move it in like that much, which I won't be able to do because I won't be able to clear this piece, it's not going to work. So yeah, and I just realized this as I was testing it in here. So this hole is that's not going to work. So I have to come up with something, or I just use one screw, and no, I need to. So I need to figure this one out. And finally, the last detail, the bearing boxes, or the bearing blocks, or the axle boxes, whatever it's called. So the idea is that I would have this here, and that's just going to cover the end of the axle and the bearing, and I would probably have to, well, not probably, but definitely I have to screw 3 holes into this bearing block. So these are the screw holes, and I think that would definitely clear the bearing inside, and probably these are going to be some really shallow holes with thread in it, and I can use some really small screws just to hold this in. And I still have to work on this a little bit because there is a recess here for the bearing and also the axle, but on some of the bearings the axle sticks out just a few millimeters, so I have to make this a little bit deeper, and also there are some numbers and letters here, so I need to carve out a little bit space here as well on the side of this 3D print, so it will a flush sit around here and then clear these letters. And maybe since I do that, I can just make this as big as the actual bearing block, so probably add a few millimeters on each side, So it goes all the way until the end of the bearing block and sort of goes all the way here and there. And I think it's going to look a little bit neater than the current version. Luckily, I only printed a single copy from this. So let me show you the design that I did, and this time you're not going to see my face in the corner because I just did that recording and the audio was really bad. So I think I'm hitting the limit of my laptop with the Fusion 360 and OBS and the camera running at the same time. So first I wanted to show you the various 3D printed stuff that I did, and as you can see the various grills and well that nameplate is that is something that I've done in the past as well. But if I look at this, let's say this grill, and if I manage to find this in the hierarchy, yeah. So I started this habit of creating a component for every single object, because once you create a component and then you, I don't know if it's this one or that one. It's this one. So when you create a component and you select it, then the timeline is going to be limited to that component. So if you have a really complicated object, instead of having a massive timeline with all the changes for all the different objects, at least you can look at the actions that you have done for this particular one. So as you can see, it is actually fairly simple. So I did a sketch which contains the drawing, which, can I open this? Yeah. So it's like the outline of the main, and this is the race section. I also added, no, the holes and everything is not here. So I just extruded all these sections into separate bodies. This is what I like to do. So, the main thing was a body, this race section was a body, and then at the end I just combine them. And then I would draw these holes and bolts in a separate as a separate sketch, and I again extrude them. And then finally, when that is done, I created a sketch on this face with these tooth basically. Oh, I think I only did one, and and I extruded them all the way to here. And then here you can use, you can see that I use the pattern just to create a duplicate, because at least I can get that spaced evenly, and I can play around with the spacing and everything. And it's much easier to visualize it when you are copying 3D features, as in trying to draw the outline, and then once you extrude it, you realize that it's not really the the good spacing, and then you have to go back and then finally I would just combine everything. So this combine tool. So I ended up having probably 3 different objects for the frame, and all these being separate objects, and I would just combine them into a single 3D object that I can just save as a mesh and put it into my 3D slicing software. And yeah, even though I have an FDM printer, I think it turned out to be great. And probably this is the scale where the FDM is still gives decent results, and you don't really see the layers, or at least you can send them away fairly easily. Or in my case, I just used spray-on putty or filler, and I haven't even bothered sanding. So I just given a couple of light coats until it was the sort of the quality that I expected. It already hides the layers, but it's not thick enough to mask some of the smaller details. And to be honest, these details are not really small at all. And for example, there is this one, which is that's where you will fill in the sand. Yeah, it's a very simple object. Yeah, just a couple of different, extrusions of various thicknesses of cylinders with this handle, and then a lot of the details rounded off. So this probably took 15 minutes to do. The more complicated objects are actually on the front. and these are these brake levers, or the brake line levers, or what it's called. And these are here. So actually this is one component with a lot of different details. It's not like how I explained it previously. So you can see that I've designed actually two of them. Yeah, that was original design, to have two of them side by side, but there is not enough space. So I'm just going to have one here, and then the other one is going to be over here. And that's going to be good enough. And that's the receiving part for the hose, with a sort of like a feed which has a hole for a magnet. So if you see, there is a hole there on the other side. Fortunately enough, the magnet is strong enough. And you can see this also made up a lot of different sketches. So I started up with one sketch which had this oval object which I extruded. I think I extruded in 3 different places. Oh, no, there was a higher diameter, there's a lower, not diameter, but radius. And I just used the rounding tool, the fillet tool, to round it off. And then, you know, this was a different sketch. You can see I created a perpendicular plane so I can draw the outline of this varying cylinder. And I think I just used the revolve. Yep, just to create a circle object. And this was another plane. This is that revolve, and I added these nuts as a separate drawing. And again, this probably ended up being like 20 different objects that I combined into a single object at the end. Similarly to this is like, yeah, you can see there is like a sphere in it, and cylinders and some boxes. This is more like a random thing, and it usually not as bulky in real life, but I wanted this big cylindrical base so I can have a magnet inside. So that was the the brake lines. And then finally I have done one more thing, which is in the bogie. Where is it? It's here. Because originally I decided to have some steps, and I was planning to put the steps on the side of the main body. So I wanted to weld this on, but then I realized that if I need to lift it off and I need to place it somewhere, then it's going to sit on these flimsy steps, which are definitely going to just bend and then broke off. So I decided to reuse these parts, which is already laser cut. So I have it laying around somewhere in the garage, and I came up with this really complicated piece. Let me switch off a group. Yeah. So this really complicated bend piece to mount it on 2 holes here, and then it's going to come up here and then go back and then go over this hole as well. So I can mount it in 3 places. Not that it really needs that much mounting. I think probably I can cut it here because it's a 2 mil plate. It won't have, you know, so much rigidity anyway, but it's going to be good enough to hold these steps. And I designed these steps to be just a few millimeters off this axle cover. Oh, I forgot to mention this axle cover, but it is somewhere here as well. Yeah, actually I'm designing another locomotive, and I had this cover for that, and I just imported it, rescaled it, and I added this plate that's mostly like a mounting plate. As I said, there's holes here, that should receive an M4 screw, and that should screw into the bearing block. I think there is enough space for a small hole there that I can tap, and that's going to receive the screw. And this is the recess that I was talking about, that I need to make a slightly bigger version of that recess, and also extend this sort of plate all the way to the end of the bearing block. So that's one. And so I have a couple of 3D printed to be done, and there are, you know, a few laser cut pieces that I would need to order at some point. And that was all the, the smaller bits and pieces. And then I also started working on the cab, which you can see here. So the idea is that, well, first of all, I'm going to have this cab, which is like a cab body, and I'm hoping to mount this somewhere within, into the main body. So when I lift the body off, then the whole cab assembly comes off with it. So again, this is just cosmetic. So I wanted some sort of box structure, so it is rigid enough. And of course, I wanted these back walls, so it's going to hide all the wiring and the batteries and everything. So it looks like a real engine when you look through the windows. And this shelf is where I'm going to have most of the cab details, which are going to be 3D printed. I haven't even started designing it, but I'm not planning to cut this from metal. So I have quite a few MDF, 4mm MDF plates at home, and I have my own CNC router. So I'm planning to cut this on my CNC. Again, just because I can do it, and of course save cost and probably weight as well. And for this, I've come up with a very complicated and convoluted process how I design these, mainly because whenever I work on my CNC, there are a set of programs and tools that I used in the past, and I just wanted to use it in the future. So before I started 3D printing and laser cutting and everything, I was designing everything in 2D, and I was so for that I was using just plain AutoCAD, and there is a CAM software which is called Vectric Aspire. And as I said, I got used to it quite a lot, so I wanted to use this for this project as well, or this part of the project. But because of the 3D, all the 3D model is in here, I wanted to design it in Fusion 360 because I have the entire model. I can easily, project features and everything onto my plane, and it's much easier than to design it completely separately. So what I have ended up doing is, for every single component, you see there is a big plate on the bottom, and there are two plates here below the windows. And there is this shelf where all the controls are going to go onto. And there are two sides and then a couple of back walls. And the reason we have a few of them, because I wanted to have this recess so it doesn't go over to the holes where we have the kingpin and the slots for the cables to come through. But also I wanted this a wall back enough so the door can open. And for each of them, I've created separate sketches, which contains the outline and some of the other construction drawings and some other details. And what I managed to figure out, that if you these are the bodies, but these are my sketches. So there is one sketch for every single body, as you can see. What I noticed that you can right-click and save the drawing as a DXF. So then I can import the DXF into AutoCAD, do some post-processing on it, and start designing my cut layouts and plates and everything. And then I export that to another DXF, which I can import into Aspire, and I can do the CAM planning. So let's see how that's done. So first of all, I export all the different sketches here once the design is finalized. And then I import all these DXF files into an AutoCAD drawing. And what I've already done that, and you can see that all of the different components are listed here. And I also did some text, and I put them in different layers with different colors so that I can see all of them. But before I can do these, I had to do a lot of cleaning because let's say there was a DXF like that. And as you can see, some of the construction lines are coming through as solid lines, so I just had to delete. And also, for some reason, it had some additional lines as well. Again, maybe some of these were construction lines, and there is a lot of overlapping lines and objects, which, for example, here you can see they are overlapping, which I had to clean because what I noticed with Vectric or with Aspire is that it prefers the drawing to be a closed polygon. So if I want to cut this, then it should be a closed polygon. So I had to delete all these extra lines. But sometimes it's difficult to see, because if there is an overlap, like a duplicate of this line, you wouldn't need to notice. But luckily there is a really good tool in AutoCAD, which is called an overkill. And that basically deletes any objects within this tolerance. So overlapping objects, partially overlapping, completely overlapping objects. So if you run this, and of course I have to delete some of the lines here. I'm not sure what this is, but I think this is not, well, probably that one is required. And I think probably this one is. So anyway, I should have deleted it before. But once you have deleted all the lines that are not required, and they use the overkill to delete anything which is overlapping, you can select a line and do PE, which is polyline edit. So yes to turn into a polyline, and then join to join them into a single polyline. So that's not going to work because I still have some overlapping stuff here. So what you can see that it shows now that 23 segments have been added to the polyline. It shows here that it's open. So technically this polyline is closed, which is what you want, which means that, you know, it's closed, it's able to find a polygon and it's fully closed. And if you click on it now, you can see the whole thing is selected. So this is what Aspire likes. Yeah, so that's how it looks like. So this is what Aspire likes, that it has some closed polygons. So I always do this, and this is how I clean my various components. And obviously anything which is inside that has to be a closed polygon as well. And once I'm done with all the parts, then I can create these boxes. So I try to arrange all my components into a 350 times 400 millimeter sheets. And I have a bunch of these in my drawer. So when I need new materials, I would go to my, no, it's not lumberyard. It's like, yeah, it's a DIY shop. And I asked like a big sheet of plywood or MDF to be cut into these 350 by 500 pieces, because that's well within the bounds of my CNC router. So I like to work with these because there is probably about an extra 5 centimeters on each side. So there is not a chance for the router to run into its extent, which I don't like. So anyway, and it also has some holes because this is my new fixing method. In the past I used double-sided tape, and then I decided I'm just going to use small screws. So I have a template plate with all these holes, and if I need to work on a new plate, then I just put the same holes in. I just drill through them, and at least I know where the screws are, and I can design my parts around these screws. Obviously in this case I'm not going to put in the middle screws, only the ones on the side. So now I can manually arrange all these parts. So I can just select this and then do copy, and then, you know, create a copy, rotate it, and then place it randomly, well, sort of randomly. Make sure that I have enough clearance between the parts, and there is enough material left within. So when it's cut, then there is still material which is going to hold all the pieces together. And yep, I just arranged the stuff like, yeah, I need 2 of these and then 1 of these, and I ended up arranging 5 of these plates that I need to cut, which contains all my parts, and there is not too much material wasted. So once I have done that, I can export all of these into separate files again, like, you know, plate 1 or batch 1, batch 2, batch 3, and batch 4. And again, just to make my life easier, what I usually do is I move all these plates. So I just copy, I create a new drawing, and I paste it in, and I say move. I pick this corner, and I say 0, 0, 0. So it moves it into the 0, 0 position, because that's the position the Vectric is going to use as well. So now I can save it yet again in the XF format, and I can open Aspire. So within Aspire, I create a new project, and it has all my defaults. So 350 by 500, the Z 0 is on the top, and the lower left corner is my home, so the 0, 0. And next I can import my vectors. So let's say the first plate. So because the DXF is also 0, 0, now it's, you know, it's all in the correct position. I don't have to move it. I don't have to realign it. It's much easier that way. And I usually save the project here as well. So if I need to make any changes to it, then I don't have to start it from the beginning. And I pin the toolpath and I start designing. So in this case, I need to cut these slots. So I use profile, and I'm going to use this 1/8 inch end mill, which is 3.175 mil in metric. And these are the parameters that I use for plywood, but that's going to be good enough for MDF as well. And this one has to be cut inside. And of course, this slot is 4 mil because I'm going to use 4 mil material. So 2 passes, like back and forth with the 1/4 inch end mill, is going to mill all the material out. So there is nothing going to be left. So I can just name it slots and then calculate. And yeah, I get a warning that it's going to cut through the material. And I'm okay with that. And if you zoom in, you can see that the path goes within the bounds. And of course, this corner is going to be rounded because, well, the radius of the end mill, it won't be able to cut into 90 degrees, obviously. So that's fine. And I can select the next two, go back, that's a path, but that's going to be a path on the outside. And I want to add tabs. And so in the past I used double-sided tape, but that's why the holes are here. So I'm going to screw this down to the waste board, and I want tabs to hold this material in. So don't cut all the way through in these small spots. And the reason I'm doing it, because I realize it's much easier once everything is done. I just take my orbiter sander when the whole plate is still fixed to the router, and I just clean the surface with, you know, just remove all the burrs and everything. So that's going to be the small components. And I'll calculate. Oh, yeah, calculate. And you can go back and see that it's cutting on the outside. Yeah, that's good. And finally, I need this big one. And I can also want to cut on the outside tabs. For this, I would probably need more tabs. It's mostly just a gut feeling, and also I want to make sure that the tabs are away from any of the corners, so it's easier to cut them in the straight sections. So I do this, and that's going to be the big one. Big. You don't really have to name this, but these names show up in the Mach 3 when you cut it, so it helps to understand where the you know, how the machine is progressing. So this is on the outside, so that's good. And at this point, I can also preview all these. So now we can see that everything is cutting through with the tabs still remaining in these places. And this is fully hollowed out. That's the slot. So again, you know, if there would be a small amount of material left in here, you probably want to add tabs, because otherwise, if it's a free material, it can jam. And I mean, if it's a small one, probably it's going to just fly away. Otherwise, if it gets wedged in, it can break the end mill. So now I can close this. I can select all the toolpath and export them and save it as a text file, which is going to be the G code for Mach 3. And that's it. So as I said, it would be much easier because I can do all this cam planning in like this toolpath in Fusion 360. I don't know how I would be able to do all the panelizing in Fusion 360, but I'm pretty sure there is a tool for that. But again, this is the process that I got used to for so many years, and I just want to carry on with it without learning this part in Fusion 360. So now all I need to do is copy these text files to a pen drive, and take it over to the CNC mill or the CNC router. But I still need to do some housekeeping with the CNC router, so that's probably going to take a couple of weeks, which means that that would be on the next video.
So that will be all for today. Thanks for watching, and hopefully see you next video.